Okay, for this example, we're going to look at unit vectors. This says find a unit vector in the direction of that and verify the result has a magnitude of 1. Now, that's why it's a unit vector, because it has a magnitude of 1. Unit vector is related to this, it being a magnitude of 1. And it makes sense, too. The unit circle has a radius of 1. It's a unit, okay? In fact, let me go off on a tangent here. This unit vector right here...
Wait, tangent?
No, quiet. Yeah, actual talking tangent.
Like a rant.
Never mind. Okay.
Never heard of that.
You guys like freak out. I say go off on a tangent. You're like, wait, tangent what? Tangent theta? Wait, I don't see a tangent theta anywhere. Okay. This right here is a unit vector. This is a common unit vector. We commonly know this unit vector as I because it's it's at the origin and it's 1 unit long and it's on the x-axis. Okay, we call that I. I is represented by 1 and 0. Okay, now this is important to know.
Wait, in the homework?
What's that? Yeah.
In the homework you
This is always what I equals for your homework right now.
I distributed it. Like,
okay.
I used it as a verb.
Yeah, you do distribute. Okay. Now, I have a question for you guys. This is a unit vector. Is this one a unit vector?
Yes.
No. Yeah.
What's this one's magnitude?
1.
Therefore, it's a unit vector. Okay, but it's kind of weird because it's not in the origin. We like them to be in the origin. It's not in standard position. I have a question for you guys. Is it still a unit vector if I move it right here?
Yes.
Yes, it's still a unit vector. Is it in standard position?
No.
No, it's not, because its initial point is not on the origin. Okay, so that's that guy right there. Let's see. I'm gonna erase him. The other guy goes this way on the y-axis, and that one's commonly known as J. So I put J, 0, 1. So now that you guys know what unit vectors are, how do we make this one into unit vector? Because this is not a unit vector. This one actually is a lot longer than that. You guys know what the magnitude is for this one?
2.
Probably not off the top of your head, but we could graph it to kind of get a visual representation of it. Let's graph this vector in its standard position. In its standard position would give us the the initial point right here, and then I'd have to go up to 2, 5. Now 2 is right here, and 5, well, that's up there, right? So let's see. The point would the vector would probably go something like this, right?
What?
Does that look like the vector right there? Yeah, it does. It does. And maybe I shouldn't put the arrow there yet because it technically goes higher than that. Okay, that's approximately what this vector is, but that's way too long. I need it to be a unit. In order for it to be a unit vector, what do? This is what you do. You take the vector, and then you divide it by its magnitude. Actually makes sense when you think about it.
To find the unit
Okay,
vector.
to find the unit vector. Yeah. So here, check this out. The vector is -2, 5, right? -2, 5. And then what's the magnitude of this dude? Let's see. Magnitude of this dude. Oh, Brad 29. Look how fast she goes. Okay, it's -2, and you got to square that foo, and then you got to square the 5. You get 4, and then plus 25, which is where you get the radical 29. Okay, so we got to divide this by radical 29. Divide this vector by radical 29. So that means it's going to be -2.
That says 9.
Did I do something? Oh, I forgot the 2. 29 radical. Okay, so I got -2 divided by radical 29, and 5 divided by radical 29. That is the unit vector. And just to kind of give us a visual representation, why don't you guys tell me what approximately that is? Using your calculator, go -2 divided by radical 29. Tell me what that is approximately. What is it? Okay, so it's -3.7, or I'm sorry, -3.7, blah, blah, no, -0.37. Okay, let's go like this, -3.7. And then what's it when you divide 5 by radical 29?
0.928.
0.928. So 0.92. Actually, it'd be 3 if I round it. Okay. So this vector right here, is that a unit? Well, here, check this out. If I was on this unit circle, or not unit circle, but on this graph, right there would approximately be a unit, right? You guys think that would be a unit? Maybe a little more? I don't know. Here, let's graph it. Let's see, negative 0.3. Well, this would be 0.5 right here, right? And this would be 0.25? 0.25? So 0.3 would be about
The middle of the
right there. Okay. Yeah, hey, check that out. It's right there. Okay, now what about this one? 0.9. Let's see, this would be 0.5. That would be 0.75. 0.9 would be about right there. Almost 1, right? Check it out. So this right here is 1 unit long. Now, how can we be sure, 100% sure that that's 1 unit long? Well, this says find the magnitude. Well, that's kind of the same idea of what I'm about to say. The magnitude would be found by this triangle using the Pythagorean theorem. We can say this is -2. Actually, it's a distance, so let's just keep it positive. Doesn't matter. The negative part is just so that you know the direction is this way. So it's 2 divided by rad 29, and this would be 5 divided by rad 29. Not 5. Okay. So how do we find this? Well, Pythagorean theorem says if you take 2 over rad 29 and square that, and you add that to 5 over rad 29, and square that, that should equal c squared. When you square this and add them together, what do you get?
1.
Yeah, you get 1. Pretty sickness. Did you say sickness? Okay, that's 1 equals c squared. So what does c equal?
1.
Uno. So that means we know that the distance right here is 1. Ah, that's pretty cool. That's how you find and create your unit vector. Oh! You guys remember the unit circle?
Yeah.
Check this out. I can superimpose that on here.
Just drilled.
I'm doing it. It's not going away.
Oh,
Dang. That was pretty close to being good.
Yeah.
That's pretty good. Do you guys know what this vector is? You guys should know this vector right here. What is that vector? No, the vector.
One.
What's the vector?
2, red 2 over 2.
Yes, you were
Red
halfway
2
there.
over 2,
Sorry.
Red 2 over 2.
Red 2 over 2 and red 2 over 2. Yeah, I only heard one red 2 over 2. Anyways.
Wow.